Hi there, my name's Ben Martins and I work as an application specialist here at Pico in the UK. Today we've got a little short video on a crankshaft sensor fault or an intermittent issue with a little Vauxhall Corsa. It starts off at being slightly interesting in the fact that there was no fault codes, however it moves on to actually having a fault code, which is slightly less interesting. But hopefully there's a few tips and techniques within the video that will help with using Pico 7 as well. So thanks very much and enjoy.
Hi there everybody, so I've got an interesting little case study here. It's not interesting, it's relatively straightforward, but it's always interesting when you don't get any fault codes. So this is a 2006 Vauxhall Corsa. It's got the 1.2 Ecotec engine in it. Now what we've got is intermittently it will cut out. Sometimes it won't start either. There's no fault codes on the dashboard and there's nothing that flags up when it is faulting. So a quick scan check actually didn't reveal anything, which is a bit slightly annoying. Yet sometimes it will crank with no start. So crank no start, obviously we're going to be looking at fuel, spark, crankshaft sensors, things like that, powers and grounds, etc. So immediately what I did was I got hooked up WPS into the fuel pressure rail, and underneath we have a crank sensor, which hopefully you can just about see through there, and we have that back pinned out on the two pins. This is a floating sensor, so obviously we have to back pin both sides, and then if we want to do any calculations we can use the maths channels within the Pico 7 software. What's really interesting is when we're watching this sensor we can actually see that the amplitude sometimes changes, so between the two channels. Now as I said, this is an intermittent fault as well, so the likelihood of it playing up whilst I'm recording is very, very unlikely, but I have managed to get some pre-recordings of this with it actually faulting. So there we go, so we can actually see that just there all of a sudden it's just changed its amplitude. Now the actual note of the engine is still the same, but we can clearly see that we've got something going on that isn't quite right, that something's changing. You can see there. This is just coming from the sensor, so this is, like I said, it's just purely a inductive sensor. It is floating. I hear a lot of people say we should be actually back, or at least checking at the ECU itself. The ECU is buried on this, so to actually try and get to it is a bit of a nightmare. But what we thought we'd do is, based on ease and accessibility, we've just gone straight to the sensor, and already we can see that something isn't quite right. So what I'm going to do is I'm just going to leave this recording and we're just going to see if we can capture this on the screen. You can see here that the engine is actually up to temperature as well, so another interesting point to make. This actually was first noticed by the customer after they'd been on quite a long drive, pulled up, got out of their vehicle and went to the shops, and then come back out and the vehicle wouldn't start. Left it for a few more minutes and then it did actually start up. So we do think that we are looking at a temperature related fault. And as I said, the likelihood of this actually doing it now is probably very unlikely, but we're going to keep watching and keep filming and hopefully we'll get to the bottom of it. What I'll do is I'll actually put the camera down on the engine bay and I'll record my screen at the same time, so when the fault does happen, actually I can quickly catch it at the same time. You should be able to see that the engine and the engine note will also change as it tries to recover from a complete loss of what would appear to be a crankshaft position sensor. Okay, so to save having to keep running this, what we're going to do is I'm just going to go back to where the actual fault occurred. So hopefully in the video we should be able to pick out where the fault happened. So obviously we can use the buffer waveform, we can run back through the captures, and we can see here that we had an intermittent dropout in the crankshaft position. Now if we zoom in on this slight patch here, what we can actually see is that the crankshaft sensor has actually shorted itself together, so we can see the amplitude is massively reduced and we've actually lost this pattern in where we should have an opposite or a mirror image of the sensor, but at that point in particular, that is where we get this, where it's actually joined together and it's actually outputting the same signal. So it must mean that they've joined themselves together. So what we can do is we can do some simple maths, just using the built-in maths channels in Picoscope 7. If I just do A plus B and A minus B, get rid of fuel pressure, I know that's not the issue. But can you see there that actually by adding the two together we can quickly see when something's actually changed. And also when we've got the true amplitude by doing the A minus B. So zoom in around this a bit more. Get a bit closer, you can see there that actually it's lost its signal completely. Actually when we're adding the two together, we actually get a much bigger amplitude or output, because now they're both the same. Alright, so what I'm going to do now is I'm going to get that crankshaft sensor out. We're going to have a little look at it. I believe it is temperature related, so when it is shorting itself together, what we'll do is I will try and put some heat onto it and see if we can actually get the resistance to change using the resistance lead, and hopefully actually prove it one step further. I mean, I'm fairly confident that even from that actually we can already see the problem, but yeah, let's do a bit more digging. Right, cheers. Okay, so as luck would have it, this car has now changed its fault condition as I took the crankshaft sensor out and couldn't get a resistance reading off of it, put it back in, and now I actually have a fault code. So for those of you that are using the mongoose lead that we get with the MVH kit, you can actually use something called the J2534 toolbox that comes with the program. This will allow you to read some actually vehicle emission related data and trouble codes. So as you can clearly see now, we have a crankshaft position sensor A circuit fault. So pretty confident that it is a crankshaft position sensor, so I will get one ordered up. Hopefully we'll get it fitted and then I'll be able to update with a post capture and hopefully a known good as well. Alright, cheers guys. Okay, so we're back on the Corsa. We now have a new crankshaft position sensor. This is a blueprint one, which I know people are probably going to argue with me and say I should have got a genuine one, but when costs come to it, this is actually pretty good and also quite expensive for what it actually is. So what I've actually done is I've got it set up with just using the resistance lead, which is part of the 4425A kit. This bit's going to be fun because I want to try and show the results whilst I actually measure it. So we'll see how we get on recording this. So what we're going to do is we're going to take the original one. I'm just going to set the scope up here just to record, just to get a bit more time on the screen. So if we can see on there, we've got 20 milliseconds per division. We're running at the moment, we're between minus 500 ohms and 2 kilo ohms. You can put this on auto as well actually, and it will do what it needs to do. And I've also added a measurement on there as well. It's just the mean. Now, if you're in streaming, obviously that doesn't get updated to the end. But if you're in block mode, so anything under 200 milliseconds per division, it will actually update every time. So a bit like a multimeter view. So what I do is I'll capture my screen at the same time so you can see what's actually going on. So we'll start off with that. This is their original. And if I connect across there, actually the results that we've got is channel still over range, so indicating a open circuit. Now if I connect, doing the same thing to the new one, we should hopefully have a resistance. That's what we're looking for anyway. And there we go. So with the crankshaft sensor connected, I've now got a reading of about 900 ohms. And there's just a bit of a baseline to give us an indication as to what to look for in the future as well. So I expect what's happened with the old sensor is that it was intermittently potentially shorting out together like what we saw earlier, saw in the previous captures, and now it's actually gone to a fully open. So hopefully, fingers crossed, this one is now, there's a clear difference between the two, so popping that one in should see the fix, fingers crossed. Right, okay, so crankshaft sensor has been fitted. We have cleared the codes out using the J2534 toolbox, so we're all clear. So we're ready to start it up and test it again. Now, a quick little tip. if you're going back to like after you've got your sort of faulting condition capture, it's worthwhile going back and loading that back in. One, because we can actually create a reference waveform of, say, let's do A and B. So this is when it was faulting. But also, if you've got a 4425A scope with BNC Plus, if you recorded it with BNC Plus probes, when you go to start it up again, it will actually give you a probe mismatch. So it's obviously asking which things match. Now obviously I had WPS on here originally. If everything matches up the same, then obviously it will just go straight forward. I'm not going to do WPS this time because I know it wasn't the problem. So I'm going to just leave that as probe not detected and just click run with found probes. Now if you wanted to, I could add WPS in, and then once we've got it all connected, and it will just start the test automatically. Why is that important? Well, it just saves a bit of time more than anything. And if you think like every file you now have that's been saved with a 4425A and BNC Plus probes suddenly becomes almost like a guided test. So yeah, just a little tip. So right, so we should be able to start it up. We've got our reference waveforms in the background. You can see we're running. So I'm just going to go and start the car. So warnings lights should all be out now. Good stuff, and the engine RPM, the RPM gauge is working. So we'll come back round. Now we can see that we've actually got what you've got in the background is actually, which is quite interesting. We've got a real big difference in amplitude, haven't we? So that's something to bear in mind. But yeah, so now we've actually seen what it was before against what it actually is now, all on one screen. If you wanted to, you could separate that out, so you've got your reference at the top in its own viewport. I'll quickly do this. If I add a scope view, so there we go. So if I go back to scope 1, and if I turn off all the active channels, so I just have my reference ones, and there we have, I've got my reference waveform in the top and my now known good, or my actual vehicle, captured underneath. So yeah, all looks good though, so I'm happy that this is all sorted. So fingers crossed, no more cutting out and intermittent stalling. Yeah, I hope that helps. I hope we've shown a few little tricks that will help with diagnosing, and yeah, thanks for watching.